Every one of us knows that the access to clean drinking water is essential for humans to survive and one of our most precious resources. However, year after year, it is also becoming more and more scarce. Just take a look to the following statistics. According to United Nations Water, by 2025, over 1 billion people would reside in areas with a critical shortage of water. Besides, the worldwide demand of water is estimated to grow by a 55% between 2000 and 2050. These two facts should open our eyes to the magnitude of the problem, which becomes even more critical when we realize that water losses account up for a 30% of the total amount of distributed water. Additionally, not only economical costs are produced by the appearance of leaks, but health issues and environmental problems too. So, can we do something as a research group to help to overcome this problem? Well, before answering this question, just a little recap about how the appearance of leaks is actually managed. On the one hand, their presence and appearance at water distribution networks must be detected, that is, their existence must be verified. On the other hand, in order to be capable of fixing the leak, the maintenance team need to know the location of the leak in the network. By performing these two processes, water utilities drastically reduce the time between the appearance of the leak and its repair, and hence the amount of lost water. Our research group mainly works on developing new leak detection and localization methodologies, working together with water utilities to help them to rapidly recover from the abnormal state produced by the leak. Currently, most of the developed and even implemented leak detection and localization strategies require a model of the hydraulic behavior of the water network. That is why they are known as model-based approaches. However, this type of methods is limited in several ways. First, some water utilities may not have a detailed model of the network, and even if they have access to such a model, it may not be well calibrated. Moreover, most of these approaches require a sufficiently good estimation of water demands in order to fit the model. Trying to overcome these drawbacks, our research group is currently working on data-driven methods, which reduce or even remove the necessity of hydraulic model. Concretely, we have been working and continue working on different lines of research, mostly in the field of leak localization. One of them relies on the application of learning techniques in order to train a classifier to identify the leak. This could be considered as a mixed model-based data-driven technique. Besides, data-driven methods have been developed to solve the sensor placement problem on water networks. Moreover, graph theory has been applied to solve the leak localization problem too, due to the clear relation between a network and a graph. Concepts from this theory have been applied to develop interpolation techniques that allow to estimate the pressure at all nodes of the network from the information of measured ones. To complement these strategies, the globalization approaches have been developed to compare leak and leak-free scenarios, allowing to select good candidates to be the origin of the leak. Several works have been published or will be published about these topics. You can find here the references in case that you want to get familiarized with the mentioned lines of work. Finally, we consider it important to highlight that the last article deals with the application of some of these developed techniques to a concrete benchmark, which was provided as part of the Battle of Leakage Detection and Isolation Methods of 2020, in which we achieved a remarkable third place.